Okay, so this is the second video for Math 1105 for the section Rational Functions. In the last video, we looked at vertical asymptotes. In this video, we'll look at horizontal asymptotes. You don't necessarily have to watch these videos in order. I recommend that you do just because that's how it would be done in class, but really horizontal and vertical asymptotes are different things. So we talked about a vertical asymptote being an imaginary vertical line where the graph cannot touch and also goes to positive or negative infinity as we get near it. A horizontal asymptote can be intersected. You can intersect a horizontal asymptote, and also it kind of tells you where the graph tends as we go to positive or negative infinity. So eventually, where would the graph settle? That's a horizontal asymptote. So we're going to see some of these whenever we start talking about exponential functions. There we go. So for an exponential function, it'll have this shape. And as we go to the left, this graph is going to eventually approach the x-axis. It could also have this shape. As we go to the right, the graph will eventually touch the x-axis. So in this case, it will never, eventually approach the x-axis. In this case, the graph will never touch the horizontal asymptote, but that's not unheard of for a graph to cross a horizontal asymptote. But now let's figure out how we find them. So what we need to remember is that these are where the graph goes as x gets very, very big or very, very small. So big in a positive way or big in a negative way. I like to take this back to fractions themselves. So whenever we have a fraction, we'll just call it fraction. We have a number over a number. So what we want to imagine is one of these numbers getting very, very big while the other doesn't change. Or maybe one of these numbers getting very, very big and the other is growing at pretty much the same speed. This is how we talk about horizontal asymptotes. So let's think about a fraction where the denominator gets very big very quickly, or more quickly than the numerator does. So let's start out with 1/2. Now let's go with an extreme example where the numerator doesn't change at all, but the denominator does. Okay, so we have a sequence of fractions here where the denominator is growing faster than the numerator. And if you think about the value of these fractions, they are getting closer and closer to 0. And that's exactly what happens to a rational function whenever the denominator grows faster than the numerator. In other words, whenever the degree of the denominator is bigger than the degree of the numerator, it's going to go to 0 eventually, meaning that the horizontal asymptote is going to be the x-axis, y equals 0. So we'll put that little rule up here. Oh, denominator is greater than numerator, and we're looking at degree here. Okay, so whenever the denominator degree is greater than the numerator degree, the fraction, the function itself, will eventually go to 0. Now let's look at what happens if the numerator gets bigger and the denominator doesn't. So we'll go with the same idea as before. It's kind of an extreme case, but it gives us a good idea. So in this case, our numerators are growing, our denominators are not. And if you look at the value of these fractions, they're actually getting bigger and bigger and bigger and never reaching anything. They're just going to infinity. That's what happens when the degree of the numerator is bigger than the degree of the denominator. There is no place that this thing just kind of settles. It just goes off to infinity. So there is no horizontal asymptote. All right, now the one that I don't really know how to effectively illustrate using numbers is whenever the degrees are the same. When the degrees are the same, what it means is that the numerator and denominator are growing at basically the same rate. The only thing that will affect it at that point would be the leading coefficient. And so what'll happen if the numerator degree equals the denominator degree? What we do to find what it approaches is we look at the leading coefficient of the numerator divided by the leading coefficient of the denominator. And that's what gives us our horizontal asymptote. So go ahead and take a second to write these rules down, because once you have these rules, it's really easy. You just identify the degree and the leading coefficient, or you identify the degrees really, and you know the answer and it's done. So let's do an example. We want to find the horizontal asymptote of that function. Well, we know horizontal asymptotes have everything to do with degree of numerator and denominator. So let's identify those first. All right, so if you think back on 2 lessons ago when we first talked about polynomials, we find the degree by looking at the biggest exponent on the variable. There is no variable here, and what we said is if there is no variable, what that means is that the exponent on it is 0. So the degree of the polynomial 5 is 0. The biggest degree here is going to be on this leading term here, x to the 1, so the degree here is 1. Now let's figure out which category this fits into. The degree of the denominator is greater than the degree of the numerator. What that means is that the horizontal asymptote is the line y equals 0, or the x-axis. Done. That's it. Okay, so we have the answer. Let's look at some more. Okay, so we know to find a horizontal asymptote, we have to know degrees of numerator and denominator. So let's find them. All right, remember degree is the biggest exponent on the variable. So the only variable here is x, or the only term with the variable is x, and it has the first power. So the degree of that polynomial is 1. The degree of this polynomial, well, we just have an x there also, so it's also 1. So we're not in the position where one part of the fraction is growing much, much faster than the other. They're both basically growing at a linear rate. But these leading coefficients right here are going to change that. It's going to tell us which one is growing faster and how this fraction is growing because of it. So we find our horizontal asymptote in this case by taking the leading coefficients. So our horizontal asymptote, if they're the same, is going to be y equals leading coefficient, 12, over leading coefficient, 3. So the horizontal asymptote here is the line y equals 4. So eventually this thing will settle out at y equals 4. Okay, one more. Now, guess which one we're going to do now. We did one like this, we did one like this. This is going to be the next one we do, but we'll talk about what to do and why you should get kind of excited about it. Okay, there's our function. We know if we want to find horizontal asymptotes, we have to know something about the degree, so let's start there. Okay, so we're looking at the biggest exponent on the variable, and in this case that would be 2. Biggest exponent on the variable, in this case that would be 1. Okay, so this time we're in the position where the degree of the numerator is greater than the degree of the denominator. So like we said with the fractions that we talked about, what's going to happen is that as x gets very, very big, this numerator is going to get very big much more quickly than the denominator will. So overall, this function's never going to approach anything. It's just going to get bigger and bigger and bigger. And because of that, there is no horizontal asymptote. So the answer there is just none, or no horizontal asymptote.